Section 10.3 has to do with arcs and chords of a circle. There's several theorems in this particular section. Theorem 10.2 says in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So in other words, here's a minor arc, AB, and here's a minor arc, DC. And I can say AB is congruent to DC or CD, however you want to do it, if chord CD is congruent to chord AB. So if these two chords are congruent, then those two arcs are congruent. A few terms in this particular section. I've got in this particular illustration, this triangle, triangle ABC, is inscribed, so it's inside it, inscribed within circle D. That's one way we can state this. Each of the vertices lies on the circle. I can also say circle D is circumscribed around triangle ABC. So circumscribed means it's on the outside of, but each of the vertices of the polynomial is on the figure that's on the outside. Circumscribed means it's outside. Inscribed means it's inside. Theorem 10.3 says, in a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So this diameter, BA, is perpendicular to this chord, TV. So it tells me that TU is congruent to UV, but it also tells me that chord TA is congruent to chord VA. So if this is perpendicular to this chord, I can assume TU is congruent to VU, and I can assume that TA, the arc, is congruent to VA. That's if this is perpendicular, it's a 90-degree angle to that chord. It can be a diameter or it can be a radius. Okay, so here's an example based on this information. You have circle W and it has a radius of 10 centimeters. The radius WL, okay, so this radius right here, is perpendicular to chord HK, which is 16 centimeters. So I can assume that this is congruent to this, and this is congruent to this. Well, it says the chord is 16 centimeters long, which means I have 8 on each side. I am supposed to find this little region right here. So what I could, I know that this whole thing from W to L would have to be 10, because it says the radius of the circle is 10. But I just want to know this little section right here. So what I'm going to do is I'm going to draw another radius here. So that other radius is 10, because every radii of this circle is 10. So if I can find this section right here and subtract it from the 10, then I know this little section. So I'm going to pull this triangle out, if you will. I know this. I know this. This is a right angle. Obviously, I can use Pythagorean theorem to find this section right here, which is from J to W. So I go 8 squared plus, and we'll call it x squared, is equal to 10 squared, because I have the hypotenuse and I have one of the legs. So x squared is going to equal 100 minus 64, because I bring the 8 squared over. So I have x squared is equal to 36. The square root of 36 is 6. So this section right here is 6. This whole thing is 10. So 10 minus 6 is going to give me the 4, which is left for this right here. Okay, so the answer here would be 4 because I'm trying to find JL. This asks me to find MK. Okay, so if I've got this MK, let's see, does it give me anything else? The radius is 10 centimeters long. It tells me HL, which is this arc right here, is 53 degrees. Well, these two have to be the same, so this one has to be 53 degrees. This whole thing is a diameter, which means this side right here is 180. So to find MK, I would take 180 minus 53, and that's going to give me 127. So that's what the measurement of arc MK would be. If you feel like you don't have enough information, always go back and reread your instructions because it should give you what you need. Okay, here's another one. You have circle O that has a radius of 13 inches. So from here to here is 13 inches. Radius OB is perpendicular, so it's perpendicular to this chord CD, which means this is congruent to this and this is congruent to this based on that theorem. It is 24 inches long, which means this side is 12 and this side is 12. It's asking me to find two different things. One of the things that it's asking me to find is this distance from here to here. Find OX. So I'm going to draw another radius. I know that the radius is 13. So I know if I pull this particular triangle out, pull it out over here. So I've got a right triangle, and I know the base of it, and I know the hypotenuse of it. So to find OX, if you will, this is X and this is O, I just have to use Pythagorean theorem to find this other side. So 12 squared plus X squared is equal to 13 squared. So I have X squared is equal to 169 minus 144, because I take the X squared over. That's going to leave me a 25 right here. So X is going to equal 5. So OX is equal to 5. That's what this is right here. Now, if we look and we work on these arcs here, CD, which is from here to here. Now you notice it doesn't use 3 letters, so I know it's not all the way around here. So this is 134 from here to here. I just want to find half of it. Okay, remember this side and this side, those two arcs are congruent. So literally to find CB, I take 134 and I divide it by 2, which is going to give me 67. So each of these would have to be 67 for the whole thing to be 134. Okay. Here's another theorem. In this section, theorem 10.4 says, in a circle or in congruent circles, two chords are congruent if and only if they're equal distance from the center. So here's an example. Chord AC and DF are equal distance from the center. They're each 10. If the radius of the circle is 26, find AC and DC. So I have got, and I know it's a right angle, so I know the radius, which that would be a radius, is 26. So I can find AB by pulling out that triangle right there. I know I have the hypotenuse. I know I have this. I'm trying to find this. So I've got 10 squared plus x squared is equal to 26 squared. So x squared is equal to 26 squared minus 10 squared, which I don't know what 26 squared is. 26 squared minus 10 squared is going to give me x squared is equal to 576. When I take the square root of that, I get x is equal to 24. So this section right here, A to B, is 24. Well, I want to know A to C. So I know that A to C would have to equal 48, and that's got to be the same as DF, but it's only asking me for DE, so the DE would be half of it, or 24. So you got to pay attention to what it's asking for. But I know since AC and DF are equal distance from the center, then this chord right here has to be equal to this chord right here. So if half of this chord is 24, half of this chord is 24. These are all based on those theorems. All right, so here's another example. Chord EF and GH are equal distance from the center. It tells me EF is 24, which means each side of this is 12 and each side of this is 12. It tells me the radius of the circle is 15, and I want to find PR and I want to find RH. Well, I just found RH. RH is also going to be 12. So I've got to find PR, which is this right here. So I'm going to draw another radius of the circle. I know the radius of the circle is 15. So I can take out this triangle. So this is 15, this is 12, and that's what I'm trying to find. So again, Pythagorean theorem, 12 squared plus x squared is equal to 15 squared. So I have x squared is equal to 15 squared minus 12 squared. So that's going to be 81. So x squared is equal to 81. The square root of it would be 9. So therefore, this section right here, which is P to R, would be 9. Okay. All right, your homework on this is page 540, 11 through 34 all. Okay. Now I gave you all because sometimes it's hard to separate. You're doing different parts of the same problem for different numbers. So it works better if I give you all on these.